counter flow heat exchanger is attached to a stanter for waste heat recovery. Consider the following data. Ambient temperature is 30 degrees Celsius. Temperature of the exhaust from a stanter is 150 degrees Celsius. Temperature of the exhaust at the exit of the heat exchanger is 100 degrees Celsius. And specific heat of the exhaust is 0.42 kilocalorie per degree per kg. And specific heat of the air is 0.24 kilocalorie per degree per kg. It is also, you can also see in this figure that ambient air in, and here it enters, and this is the wave from where it is exhausted in from stanter, and from hot air to stanter. This is a typical figure of a heat exchanger. From here hot air to stanter goes out from this. So it is said that in question that at a steady state, if the mass flow rate of the exhaust gas, the incoming air are the same, assuming heat loss as 0, the temperature in degree Celsius of the air at the exit of the heat exchanger towards the stanter, rounded off to 1 decimal places. This is the question from general question from waste heat recovery part. So in this question, the simple concept that is applied as heat flow from stanter is equal to heat flow out of the stanter. That means the heat that is flowing from the stanter, that is exhaust, is equal to the heat that is flowing out of the stanter, that is from the temperature of the air. Out means this total heat from the stanter exhaust is equal to the total heat flow out of the stanter. Now we will solve these questions using the data that is given in this question. So solving this question, it is said that heat flow from stanter exhaust is equal to heat flow out to stanter, that is temperature of air. So if you calculate this heat, what is the formula of heat flow? Heat flow is mc delta T. C is specific heat capacity, mc delta T, mc1 T1 T delta T is equal to mc delta T. C1 C2 you can replace as C1 and C2. So since the mass is same for both these, so m to m got cancelled. Since C1, if you write from heat flow from stanter, that is exhaust, that is the specific heat capacity is given out to be 0.42, and delta T is 150 minus change in temperature from stanter to exhaust. If you have seen in the figure, that is written as 150 minus 100, and delta T C2 is given out to be 0.24, and delta T is, you have to find the final temperature. So T is temperature and the ambient temperature that is given as 30. So 0.42 into 50 is equal to 0.24 times T minus 30. So 87.5 is equal to T minus 30. If you will calculate this, then T will come out to be 117.5 degrees Celsius. And you have to write the temperature in 1 decimal place. So the correct answer would be 117.5 degrees Celsius. It is the right answer. So the basic concept is heat flow formula is mc delta T, and this was a simple calculative question. I think it must be clear to you by now. You should also focus on these types of questions as well, because they ask sometimes this, and sometimes they can ask from latent heat of fusion also. So just be aware of these types of questions as well for the upcoming GATE examination. Now coming on to the next question. Consider the following isotherms at equilibrium for two dispersed dyes D1 and D2 dyed on polyester. If the partition coefficient of these dyes are K1 and K2 respectively, then the value of K2 is to K1 is. You can see this equation from this figure. K2 is for D1 it is K1, and for D2 the partition coefficient is K2. So for dispersed die is D1, for die D1 we can say that partition coefficient is, the formula for partition coefficient is df die in fiber upon die in solution. The formula is df upon ds. It is the general formula for die in partition coefficient, die in fiber upon die in solution. If we talk about D1, then die in fiber is 5 or die in solution is 0.1. So we can say that 5 upon 0.1. 5 upon 0.1. It will come out to be 50. And for die D2, K2 is equal to df upon ds. In this case it is also same, but for D2 the die in fiber is 10 and die in solution is 0.05. So die in fiber is 10 and die in solution is 0.05. So it will come out to be 200. So K2 is 200. And what we need to find as value of K2 is to K1. So it is very simple. Thus K2 upon K1 is equal to, K2 value is 200 upon 50. You can solve this as 4. It will come out to be 4. The value of K2 is to K1 is 4. The answer is 4. I think it is very much clear to you. This is the entire GATE 2021 textiles part. These questions are not very difficult. Just you need to be clear with the basics. I think you like this types of solutions. So all the best for your examination. Now we'll meet you in the next upcoming sessions. Till then, keep learning. Thank you.